Let us explore two different methods to find optimum values for a given quadratic function. Optimum here is maximum or a minimum value. Let us enjoy the journey of learning. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to consider two questions where we need to find maximum and minimum values. These are related to optimization, and we are going to use the strategies learned in quadratic functions. So here is the very first question, which is based on reducing the cost or finding the minimum cost for the number of rackets. And the second one here is to find the maximum height reached when a stone is thrown upwards. So these two questions will be solved. Let me thank all the viewers and subscribers for watching my videos, posting excellent comments and suggestions. This question comes from our subscriber who wants to understand how do we apply the learnings of quadratic equations in optimization problems. So I'm going to discuss three strategies with these two examples. We'll begin with the first question, where the question here is the cost of making X tennis rackets each day is given by C of X equals to X square minus 20X plus 120 dollars per racket. So this is the cost function. How many rackets should be made per day to minimize the cost per racket? Well, the answer is also there for you. Let us see how do we achieve this answer, right? Now, as you see, the function for cost is given to us as C of X equals to X square minus 20X plus 120, correct? This really represents a parabol which is going to open upwards, right? Minimum happens to be at the vertex, this particular point. And in this question, we only want to find how many rackets. That means the value of X, correct? So that is what we need to find, not the minimum cost, right? That is all. Now, how do we do so? So here is your reference. Normally, when you have learned that equation of a parabola, which is a quadratic function, is given as y equals to ax square plus bx plus c. So this point we call, this is the axis, right? Axis of symmetry. So let me write in short, axis of symmetry. So axis of symmetry is at x equal to minus b by 2a, correct? So that is the value. So if you are given an equation standard form, straight away substitute this and get your answer. Now in our case, as you can see, we have this function where a is 1 for us, b is minus 20, c is 120, which we are not going to use, but we can now find the axis of symmetry, the x value, which is minus b by 2a. Substituting the values, we get minus of minus 20 divided by 2 times a, which is 1, which is 20 by 2 or 10. Is that clear to you? So we get our answer straight away using this formula. So what we need is that we need to, for minimum cost, 10 rackets, right? So we have to produce 10 rackets for minimum cost. Clear? So that is how we should be answering this question. This is one way. The second way is to do complete the squares, which we are not going to do in this particular case, but you can apply that. Okay. Now let's look into the solution for the next question. So I hope the concept is clear, right? Feel free to write your comments and share your views. In case you want to learn from me, you can always send an email on globalmathinstitute@gmail.com. Now let's look into the second example, which is when a stone is thrown vertically upwards, its height above the ground is given by the function which is written as h of t equals to 49t minus 9.8 t square in meters. Find the maximum height reached. So, as you can see, if I want to sketch this graph, how will it look like? Well, it should start from the ground going up, right, and coming down. So, here also we are looking at this axis, right? And the point is the maximum this time since the parabola opens downwards. How do we find this point? Now, we can also use minus b by 2a, right? So, we can say time is minus of this value, which is 49 divided by 2 times minus 9.8. So, it's also important to reorganize. Let's rewrite this equation as minus 9.8 t square plus 49t. So, once you get the value of t, which is right there, t equals 2, you can calculate this value. And once you calculate, you will find your answer. So, this comes to what? Well, this gives you a value of t, which we'll see later. No problems, right? Okay, great. So this is your method number one. Second method to find this time will be factoring. So let me factor. So if I factor this equation, what do I get? I get h of t equals 2. So let's factor t out. So that's, let's say, minus t out. Okay. So we get 9.8 t minus 49. So when we factor, we get zeros. So if I want my zeros, right, which are the x-intercepts, I get two different values of t. These two, right? So from where, when what was it thrown? So t equals to 0. And the other value is 49 divided by 9.8, which should be equal to 5. Is it clear to you? So when you divide 5 times. So 50 divided by 10. Okay. So it is 5. Well, 9.8, we always get using gravitational acceleration, right? Great. So we get these two values, which are 0 and 5. So we have two zeros. To get the axis is now average of these things, right? So axis of symmetry is for t equals to average of this 0 plus 5 divided by 2, which is 2.5. You get the idea? So we got the center value, which is 2.5. Now let me take the help of calculator since we really want to find the height this time. Add 2.5, right? So which is like, you can substitute in first or second equation as you wish. 49 into 2.5 minus 9.8 into 2.5 square, right? And calculate this value. So let's use calculator to calculate for. Okay, great. So we have calculator here. 49 times 2.5 minus 9.8 times 2.5 square. And what we get here is 61.25. So we get the height in meters. So the maximum height reached is 61.25 meters. Is that clear to you? See, we'll get the same value of t here also. Let's use calculator. 49 divided by 2 times 9.8, right? And using the calculator, I'm just finding. So this value is also 5 by 2 or 2.5. Makes sense. So you get the same answer for time, which is the axis. So first find the axis, correct? And then get the answer, right? So that is how you should be doing it. And of course, you can use the quadratic formula. So I've shown you two methods here. The third method is completing the squares. So completing the squares, we are going to check in the playlist because it has many ways of doing. Many examples will be required to understand the strategy. So the third method is completing squares, for which I'll request you to check my playlist. Perfect. So we have got the answer for both. In the second case, we found the maximum height after finding the axisymmetry as 61.25, and in the first example, we found that for making the tennis rackets, the minimum cost happens to be when 10 rackets are produced. That is what it is. You can find what is the minimum cost per racket also in this particular case. I hope that helps. Feel free to write a comment, share your views. If you like and subscribe to my videos, be great. Thanks for your time and all the best.